Question 35. The intelligence quotient IQ scores for adults in City A are normally distributed with a mean of 108 and a standard deviation of 10. The IQ scores for adults in City B are normally distributed with a mean of 112 and a standard deviation of 16. So this question has three parts. So I'll just quickly go through those parts. So part A, Yin is an adult who lives in City A and has an IQ score of 128. What percentage of the adults in this city have an IQ score higher than Yin's? We go on to part B. There are 1 million adults living in City B. Calculate the number of adults in City B that would be expected to have an IQ score lower than Yin's. And the final part, part C, Simon, an adult who lives in City A, moves to City B. The Z score corresponding to his IQ score in City A is the same as the Z score corresponding to his IQ score in City B. By first forming an equation, calculate Simon's IQ score. Give your answer correct to one decimal place. All right, so let's go back to the beginning. Part A. Okay. Now, this is to do with the normal distribution. So this is the bell curve. Now you can use your formula sheet. Obviously, it's got the empirical rule. Now I've just hand drawn it here, so I've just drawn it manually. Okay, so I'll be referring to this, so you might recall this. When you're dealing with Z scores, and especially with normal distributions, anything sort of between -1 and 1 standard deviation from the mean, 68 or roughly 68% of the scores will lie between -1 and 1 standard deviation from the mean, or a Z score of -1 to 1. 95% of scores will lie from -2 to 2, and 99.7% of scores will lie from -3 standard deviations to 3 standard deviations from the mean. All right, so we'll refer to that later. All right, so let's go back to part A. Yin is an adult who lives in City A, has an IQ score of 128. What percentage of adults in this city have an IQ score higher than Yin's? Okay, so let's see, first of all, City A, let's go back to the question. City A, the mean is 108 and a standard deviation of 10. Okay, so let's work out Yin's Z score. Okay, and that's going to be equal to his IQ score, so that's 128. Okay, minus the mean or the average Z score. So again, for City A, mean of 108, so 128 minus 108 all over the standard deviation, which is 10. Okay, so you could work this out easily enough. So 128 minus 108 over 10 gives us a Z score of 2. Now, it's asking for what percentage of the adults in this city have an IQ score higher than Yin's. Okay, so let's go back to our bell curve or our normal distribution. Okay, so we've got a Z score of 2. Okay, so what percentage will that be? Okay, so 2.35 plus 0.15, all right, that's going to be 2.5%. Okay. Okay, so okay. Next part, part B. There are 1 million adults living in City B. Calculate the number of adults in City B that would be expected to have an IQ score lower than Yin's. So now again, if we go back to our distribution, okay, so Yin's score, his IQ score is 128. So I'll go back to the question there. Okay, so his IQ score is 128. Okay, now we're dealing with City B, so mean of 112, standard deviation of 16. So what we're going to have to do is we're going to have to recalculate Yin's Z score for City B. It's not necessarily going to be the same as City A. In fact, it won't be. Okay. So let's do that first. So right, for city B is equal to his IQ, which is still 128, minus the average for city B, and for city B, mean of 112 over standard deviation of 16. Okay, so make sure that you put in the right, substitute in the right values into the z-score equation. Okay, and that's going to be equal to, okay, so 128 minus 112 over 16, and we get 1. That's a very convenient z-score. Okay, so if we look at our bell curve, okay, so there's our standard deviation of 1. Okay, now 50% of the data lies from 0 all the way to sort of negative infinity. Okay, but we're adding another 34% to 50%. So that'll be then the total or the percentage of adults that are under a z-score of 1. Okay, so okay, first of all, so from the bell curve or from the normal distribution, okay, you've got 50%, that's percentage of scores under 0, plus 34%, which is the percentage of scores from 0 to 1 standard deviation, okay, and that'll be 84%, and therefore 84% of adults have an IQ less than yins. Now that doesn't quite answer the question. We actually want the number of adults, so 84% of 1 million, okay, is going to be equal to 840,000 adults. Okay. Right, let's go to the final part now, part C. Okay, Simon, an adult who lives in City A, moves to City B. The z-score corresponding to his IQ score in City A is the same as the z-score corresponding to his IQ score in City B. By first forming an equation, calculate Simon's IQ score and give your answer correct to 1 decimal place. So first of all, we're going to let A equal Simon's IQ score. Okay. You could use any pronumeral you like, so it doesn't really matter. I could use the letter X. I didn't use the letter X, so not to confuse it with the mean. Okay, so the mean with the X with the bar on top. Okay, so what we're going to do is we're going to sort of form an equation. So, in other words, the z-score for both cities is going to be the same. So the way we're going to do this is we're going to say A minus the average for City A. So just bring back, make sure you might have to go back to this. It's on a previous page. So the mean for City A is 108, standard deviation of 10. Is equal to his z-score for City B. So A minus, now for City B, 112, standard deviation of 16. A minus 112 with A, standard deviation of 16. So we've now formed our equation. So these are the two z-score equations basically, but with the different values substituted in, okay, for both cities. And A is Simon's IQ. All right. So now we need to solve this equation. Okay. So from this point on, it's just algebra. So what I'm going to do is I'm going to cross multiply. So move the 16 over here. So 16, A minus 108 is equal to 10 outside of A minus 112. Okay. So notice that's a very quick way to eliminate the fraction, or to convert it from in fractional form to sort of linear form, okay, without the fraction. Expand the brackets, so 16A minus, now 16 times 108, so expand on that, 1728. 1728 is equal to 10a minus 1120. So that's 10 times 112. Now let's collect the like terms. So 16a minus 10a is equal to negative 1120 plus 1728. So it's just algebra really from this point on. 16a minus 10a, that's 6a. And negative 1120 plus 1728, and that's equal to 608. Now, a is equal to 608 divided by 6. Okay, so divide that by 6, and we get 101 and a third, or 0.333. Okay, sort of carries on there. And it says correct to one decimal place. Yep. Okay, so let's enter to one decimal place. So therefore, A is equal to 101.3. So Simon's. And that's it. Thank you for watching.